the Connecticut landscape and also their role in the environment. So please welcome Peter.
Thank you. I'd like to, if I trail off and you can't hear me, just throw a rock or something in my direction. I'll figure it out. I really have to thank you for inviting me here tonight. I'm on the Zoning Commission in Hartland, and we're having a rather contentious meeting. So, in any case, I'm very happy to be here, having lived through a few prior meetings like that. Let me tell you a little bit about myself. So when I was 18, my stepmother said to me, "You're an animal and belong in the zoo." And she was right. And so I wrote a letter to the curator of reptiles at the Bronx Zoo, and they were looking for a warm body, and I appeared at the right time. And so I started working there as a reptile keeper in 1954. And being a fairly persistent person, I retired from there. And, well, I didn't retire from there directly, but I stayed there. I spent 2 years in the Army, went back to the zoo, and eventually left there in 1988 as the superintendent of reptiles. And I went from there to one of the other satellite organizations that the Wildlife Conservation Society runs, and that was the new Central Park Zoo that was being built at the time. You probably read about it in the paper. And so I went there to help build the zoo, and stayed there until I retired in 1997. So although my career there was always in the reptile department in reptiles, I really, over the years, I developed a second hat. And what happened is that back in 1971, a number of important things went on in the world of wildlife, and that was, first of all, the Endangered Species Act came into being, and that regulated, that set up a sort of a system whereby this individual states would declare any wildlife and any plant an endangered and threatened species. And there were various categories of threatened or endangered. And then on the federal level, the Endangered Species Act listed anything, wildlife and plants, and wildlife includes anything from marine animals to corals to mammals, birds, reptiles, listed them as endangered or threatened and gave them special protections. And on the international level, under the United Nations Environmental Program, a treaty came into being in 1971 called the Convention on International Trade in Endangered Species of Wildlife and Plants. And the acronym for that is CITES, C-I-T-E-S. So what CITES did was it regulated the trade. Anything, any species of wildlife or plant that entered into international trade from one country to another fell under this treaty. And the Endangered Species Act on the U.S. federal level and the state regulations all piggyback back to CITES. So it's a very, very complex system. And what it also means is that some countries can say, well, my elephants are endangered and totally prohibited from any trade, but the country next door could say, well, no, wait a minute, we've got a lot of elephants and we've got to cull them because they're raiding gardens, and so we're going to kill some off, and we want to sell our ivory on the international market. And so there's this whole system of export and import documents and certifications that go on from the time the product leaves the country of origin, the elephant, let's say the elephant tusk leaves Uganda, for instance. It may get shipped to Japan. From Japan, it may get shipped to Thailand. From Thailand, it may get shipped somewhere else and eventually arrive at the market where it's sold. And there's a lot of documentation in between. And the whole thing, enforcing these regulations, hinges on the ability to take a small piece of the animal, whether it's a piece of tusk or a piece of ivory or skin, and for wildlife inspectors around the world to be able to identify the species from that product. Well, it's pretty darn easy to take, at least among some people it is, to take a live crocodile and use the literature to be able to identify what species it is. But now when you skin it and have a small piece of it on a handbag and send it out through international trade where it goes from country to country, it becomes more and more difficult, if not impossible. Well, my expertise is identifying wildlife products, wildlife species as they appear in commercial products. So that could be ivory that's carved. Right now, I periodically go to Sotheby's in New York because they have furniture that was that came from some European court in, let's say, the 1700s, and it has inlaid sea turtle. And so that sea turtle has to be identified as to what species it is, and that's one of the things that I do. So somewhere along the line, I kind of put on a second hat and became a forensic specialist in wildlife identification. And so I retired from the zoo, as I said, in 1997, but I keep my second hat because that's much more fun. And so what you see on TV, CSI and all these forensic programs, everyone that's in the forensic community really they don't watch them because they know that most of it isn't true. And there's things you can do, and there's a lot of things you can't do. And but it's getting there. In any case, part of what I've done over the years, and sort of leading into my talk tonight, is occasionally, because my real specialty is crocodiles, and sometimes one of the things that a project I just finished doing a few years ago was there's a small island country in the middle of the Pacific that maybe some of you that were in World War II perhaps remember, called Palau. And one of the small islands of Palau was Peleliu Island, where one of the major battles during the war in the Pacific took place. And while Palau has a lot of history to it, Peleliu Island, where this battle took place, something like 28,000 Marines and Army troops landed and fought something like 25,000 Japanese troops that were entrenched there for 71 days, if I remember correctly. And just think about those numbers for a minute and realize the island is only 3 square miles in size. So it's like when you're there, you can stand in the middle of the island and see ocean in all directions. So in any case, one of the things that the country has, and when I say the country, the Palau is made up of about 300 islands, but only 7 of them are big enough for people. They have fresh water and so on. And the biggest island would fit between Hartford and Route 8. It's 27 miles long. And the human population is about 20,000 people. That's outside the tourist season. There's a lot of scuba diving, and Japanese come back there all the time because a lot of their family are still buried there. But in any event, you have this tiny, tiny micro postage stamp country with 20,000 people. And my job was, I was asked by the U.S. Fish and Wildlife Service to go there and estimate the size of the crocodile population. So they share this postage stamp with about 500 crocodiles. And these, if you ever watch the, what do you call it, the crocodile hunter programs, these are the same saltwater crocodiles that he talks about in his program when he was alive all the time. And these crocodiles get to be about, the biggest one is about 18 or 19 feet long and weighs about 1.5 tons. And so they easily eat horses and cattle and so on. And in the rest of the world, where they come from, they also eat people on a fairly regular basis. Not that they like people, it's just that people are small enough, just like a chipmunk or a squirrel, they fit. And besides, they're kind of soft and pink, they don't fight, they don't have claws, and no big teeth, so they're really, really neat pieces of things to eat. And but in Palau, they don't eat people. And the reason they don't eat people, and they don't even attack people or bother people, is that the Palauans, because their country is so small, protect everything. And there are no laws that protect it. The people just automatically say, hey, stop your car, there's a crab crossing the road. So one of the things they protect is they protect a barrier reef that surrounds the country. And that's a great source of food. That's their food, human food, as well as food for the crocodiles. And about 20% of the coastline, let's say, think about 20% of the United States. 20% of the coastline is mangrove swamp. And mangrove swamp is the nursery that produces all of the breeding and all of the fry and all of the small things that eventually, the marine life that eventually ends out in the reef. So because the Palauans are protecting their total environment, crocodiles have enough to eat. So there's no reason to come after people. So you'll see a fisherman sitting there and there's a crocodile swimming across. There's a crocodile. There's another one. So we did a survey there and we figured out that there were about 500 adult crocodiles in the islands, and it was quite amazing. So what I'm talking about tonight is, yes, it's important to preserve certain species, but it's more important to preserve habitat. Because when we preserve species, we focus on one thing, and I'm including us as part of living in a habitat. As soon as you protect the habitat, you're protecting the entire environmental system, the entire web of life that habitat includes. And when we're looking at these things now, we're looking at a number of universities, including Yale, have set up what they're calling the Tree of Life. And this is, we're connecting through various departments and various scientific disciplines, we're connecting things together in ways that have never been connected before. We're putting them in a sort of a scale of time that goes back through evolutionary times, so that we can see where things are related to each other and how when the Earth was coming together in the continents during Gondwanian periods, when all of the land masses had come together and started breaking apart, how all of the wildlife got separated from each other and inhabited different portions of the world. So it's really a very, very exciting time, and I only wish I were 50 years younger so I can understand more about DNA and cladistics and all these new things that are taking place. And what I'm seeing at Yale, at the Peabody Museum, is really astounding to me, because there are young people, there are students there. One young man said to me, he says, he says, I'm seriously learning disabled. And I'm in the PhD program here, and I'm studying genetics. I'm working on genetics. It's just incredible. My wife, who teaches at Naugatuck Valley Community College, had a young lady from Yale. And here's this young little thing about yay big, probably weighed 100 pounds soaking wet. She's from a minority group. She got a full scholarship at Yale. She went to her advisor, and the advisor said, what do you want to study? And she said, lions. I want to study what lions eat. Well, their philosophy is if you're accepted into the program, there's unlimited money for you to do what you want, so long as you approve. So she went to Tanzania by herself and lived out in the plains with local villagers, studying how lions hunt their prey and the effect that lions and predators have on the environment. Unfortunately, there were a couple of lions at the time that were eating people regularly, and they became part of her study. And so there was this young lady all by herself that spent an entire year living in the plains of Africa studying man-eating lions.
And would you have thought that that's been studied over and over before, though, or no?
Well, each situation is different. And there's always, and not only is the situation different, but the technology is different. So you have the ability now with modern technology that people didn't even have 10 years ago. I spent 10 years running around Brazil chasing crocodiles and studying crocodiles and never knew where I was. Now I've got a GPS in my car that got me here tonight when the bridge was out. So, in any case, this is probably one of the most profound things profound sentences that maybe we can drop off some of the lights.
Try to find them. Look on the lights.
Okay, it's okay for me, but it's okay for you. No one afraid of the dark or anything like that. And I didn't bring any snakes, so. And this is very true. When the last animal or living thing disappears, it's never going to come back again. At least not until there's another Earth that takes place at some point in time. William Beebe was an interesting person. He was the first person to go down in the bathysphere, down, and wrote some wonderful books that are still out there. And what was interesting about him, he was with the New York Zoological Society, now it's called the Wildlife Conservation Society, but all of the pictures of him have a net in one hand and a shotgun in the other. And his philosophy was, if I can't catch it to look at it for the zoo, I'll shoot it and take it to the museum. In any event, I'm going to start off not very far from here, if I can find my thingy. There we go. This is Route 22 in New York, and the Connecticut border is right here. Litchfield County is right over there. And this is a little town of Dover Plains in Dutchess County. Do any of you know it? Okay. Well, as I said, here's Route 22. I used to live right there. And this is the heart of town right here, such as town is, Benson Hill Road, and right here are some farms. And my friend Norman Benson, his family has lived there for over 200 years and on the farm there. And one day when I didn't know he existed, and one day I got this phone call at the Bronx Zoo, and this fellow said, "Hi, my name is Norman Benson. I'm a dairy farmer." And he says, in the middle of the afternoon, when I don't have anything between milking my cows and doing all the rest of the stuff, he says, I go up on the mountainside and watch the rattlesnakes. And boy, that really tweaked my ears. And so we met, and we got to be really good friends. And sure enough, right here on East Mountain, right about there was an area that was very rich in rattlesnakes. And if you go up East Mountain, now we're in the foothills of the Berkshire Mountains, and you get up here, you have Kent, Connecticut, and so on. And there were these, well, I'm getting ahead of myself here. So what we're talking about is here's Norman's farm is here, and it was close enough that I could see the mountain from where I live. And he called me up on a nice warm day, and we'd go up on a mountain. We decided it was a good place to do a study. There's not much is known at the time was known about how rattlesnakes fit into the environment and into the habitat. And so it was easy. You'd go across this field and into the foothills and climb over all of this deadfall, and then start going up the mountain. And you get up to the forest, and you can see how the forest would change from the lowland plants, and it would begin as you got higher and higher. You'd begin to get into white pine and green striped mountain maple and hemlock and so on. And as you got up about 900 feet, you have these limestone outcroppings and ledges. And where you have the ledges and these outcroppings, this particular area faces the southwest. And that's important because now, with what we know about where rattlesnakes live here in Connecticut, here in this part of the Northeast, you can virtually pick out the habitat and say, this is where rattlesnakes either are living or used to live, because it's very, very specific. And one of the things that most of the snakes, like rattlesnakes and larger snakes, depend on are places to spend the winter. And these denning sites, and you've all heard of it, this is a rattlesnake den. These denning sites are very, very special places that are few and far between. And they almost always have to face the southeast or southwest, because in the winter they need that southern exposure of sun coupled with a blanket of snow insulation to allow them to get underground and stay above freezing. And so what we did was we got up into this hillside, up into these ledges, and we found the precise hole, the precise opening where these animals would go down and use during the winter months. Now, how many places in Connecticut have you seen places like this? This is probably one of the best places for snakes to live, particularly timber rattlesnakes. And we would go up here and we would find, over a period of years, we marked, captured, liberated again, and recaptured, about 150 rattlesnakes in an area of less than 2 miles square. Very, very small. And this was particularly good, so you could always find rattlesnakes. And I remember, and what's interesting about it is that everybody knew there were rattlesnakes along the mountains in Connecticut, but they didn't know where. And periodically one would cross the road down below in the valley, because come July and August, when it's getting dry, they come down and they start wandering looking for water, and then they go back up. And in an entire lifetime, a rattlesnake doesn't go more than about 1.5 miles away from where it was born. So we would go up, and I remember one day we were up on one of these one of these called talus slopes. This was all glacial deposit. We were sitting here having our lunch, and there were 3 or 4 rattlesnakes sitting there, just sort of, taking it easy in the rocks. And we heard voices and laughing, and here was this troop of Boy Scouts coming down from the top of the mountain, going down through this rock slab, through this talus slope, and we thought, should we tell them about the rattlesnakes? And we didn't, because rattlesnakes are really very timid. They don't attack people, they just sort of sit there. You've got to either step on one or touch one to get bitten by it. And this whole troop just went right on down in memory way, never saw a rattlesnake, and here we were looking at rattlesnakes all over the place. And this is typically the way you find them, hiding underneath the ledge like this. This is timber rattlesnake there. There are 2 of them. And it's a very complex system. What happens is that we think in terms of temperature, that it's a warm day, the snakes are going to come out, or it's a cold day, the snakes are going to be gone. And that's true to a point, but what happens is that in the life cycle of a rattlesnake, and it's the life cycle of most of the snakes here in the Northeast, what happens is that these guys come the beginning of, let's say now, mid-September, the end of September, beginning of October, wherever they are, they start returning to the den site. And this is the site where they were born. So they may have to go from the valley up about 900 feet, and they all return to these den sites. The females have their babies, and they sit there with their babies until the photo period, or daytime light period, gets short enough so that the day can't heat up enough. And the average, so in other words, there's not enough daylight for the sun's warmth to overcome the cold of the night. So it's not the individual daily temperature, it's the trend of the total environment that begins to decline. The same thing happens in reverse in the spring. So when this temperature drops, the overall mean climatic temperature, as it's called, drops down, they go into hibernation. And they stay there, and we have never seen a rattlesnake out any later than October 28th. In the other direction, we've never seen a copperhead or a rattlesnake come out of hibernation before May 2nd. So in some places they say April 27th, 28th. So it's really a very, very precise thing. So what happens is that they'll all be in hibernation. Come spring, they'll come out of hibernation, and the first thing they'll do is shed their skins, and then they'll start feeding. And the females, because there is so much energy that's taken up in having their babies, and the babies are live born. Some snakes lay eggs, but rattlesnakes have live young. They have about 15 to 20 at a time. So much energy involved in this that they can't breed every year, so they breed every other year because they need the period in between to fatten up for the next breeding time. Because when they're pregnant, they don't eat. So there's a lot of their lives. If a rattlesnake is able to get between shedding its skin when it doesn't eat, which takes place about every 30 to 40 days, and being pregnant, if it gets to eat a meal 4 or 5 times a year, it's really lucky. And the babies like to get out, hide out in dead leaves, just somewhere out of the sun, out of the wind, but still in the sun. And when you start looking around, you find all sorts of scats or deposits from everything from raccoons, squirrel, deer, fox, salamanders, and frogs. So this is a total ecosystem. And you could always identify a real biologist, because every time they find a scat, they're taking it apart to look and see what's in it. Because there may be bones and skulls, and therefore get an idea of what the animal is eating. You've got to sort of watch where you're going. Because this copperhead is just laying there right out in the open, and it's so perfectly camouflaged that you would never see it. And once I was catching copperheads up in the Ramapo Mountains with a friend of mine, and I saw a copperhead, and I says, "Oh, here's one." I went over and I pinned it down and picked it up and put it in my bag for the zoo. And he said, "What about the one next to it?" And what one next to it? And there was one not more than 12 inches away. I never saw it. It was just sort of sitting there. It wasn't moving. But last night I was watching this program, and there was this guy that was milking snakes and so on and so forth. And there are herpetologists and, quote, snake experts, and there are herpetologists and snake experts, and they don't necessarily have to be the same. And this guy was showing how he was milking a black mamba from Africa for its venom. And I kept thinking to myself, why is he doing that? Because that's for show. So don't believe all of these things you see on television. That's not the real world of herpetology. That's not what people do. Well, let's put it this way. I've been part of, when I was living in New York, when I was working for the zoo, I was in the circuit on poison control for the Bronx Municipal Hospital, Jacoby Hospital, was a snakebite trauma center. That's in the middle of New York. Why do you need a snakebite trauma center? Well, the truth is that we would get anywhere between 12 and 20 snake bites a year, poisonous snake bites, not harmless snake, poisonous snake bites a year, mostly from cobras and African vipers and Asian vipers, people keeping them as pets. Okay. So, and if we had to do a stereotype of who gets bitten by a poisonous snake, 99% of the time it's someone playing with it. 99% of the time it's a pet. 99% of the time the person is between the ages of 17 and 35. They're Caucasian. They're on drugs or alcohol. And it's always around the weekend. I can't tell you how many Christmas Eves and New Year's Eves I've spent in the ER with some jerk that got bitten by his pet snake. There's a great temptation not to go. But we had the antiserum for snake bite for all species at the reptile house for the protection of our keepers. And what happens is that we provide it as a public service, but at the same time, it's not made here. So we have to import it from other countries all over the world. And it's extremely expensive. In recent times, it's gone up 100 times in price. And generally speaking, it's not replenished. In other words, when somebody receives a snake bite because it's a life-threatening situation, there's no one that's going to pay the cost of our replacing that antidote. So it's a very, very difficult question to deal with. In any case, this is one example of a den. There's a hole here underneath the root of this tree. And we could always find snakes sunning themselves around the entrance to this. And if you would sort of stick something down there, that hole goes all the way down into the hillside. And what we did was we set up recording thermometers, one to record the temperature outside and a probe that went down into the den about 4 feet to record the temperature of the den. And what we found is that during the wintertime, even when the temperature was like minus 14, we could still, within the entrance, the warm air coming up from deep down kept, just inside the entrance, kept it up about 35 degrees. So unless there's this kind of a situation where the warm air from down below can keep that den, the snakes don't use it. So I just went to a symposium a couple of months ago in New York State where there were people that have counted all of the den sites that they could find between Pennsylvania, New Jersey, New York, and Connecticut. And the most they were able to find is about 160. That's it.
So the copperheads need the same thing?
Yep. Yep. A lot of snakes use the same thing. This is a copperhead, and this is a milk snake. And people frequently make a mistake and think they find a milk snake and think it's a copperhead. And right now, I can tell you a very easy way to tell them apart. Milk snakes have red eyes. And they're also, the pupil of their eye is round. Copperheads have a pupil like a cat's. It's elliptical.
Do they have white mouths?
No.
No.
No, cottonmouths that are in the same family have a white mouth. That's why they call them cottonmouths.
Well, I whisked the snake off the road. It looked like a copperhead, but he had a white mouth. I was just curious.
Yeah. No, a lot of snakes have, the harmless snakes have white mouths. Also, that little thing there, here's the eye, and then you got that hole, and then you got the nostril right in front of it. That hole is a pit. It's a deep hole in the cheek of the snake. And harmless snakes don't have that here in this part of the U.S. And that's why they're called pit vipers. And the reason they're called pit vipers is because that hole is lined with heat receptors. So you can blindfold a rattlesnake, and all you have to do is put something warm in front of it, and it senses that heat from about 4 feet away and strike and hit it every time. That's why snakes don't miss. Rattlesnakes don't miss. If they're going to strike, they strike and they win. So that heat receptor and the pupil like a cat is a dead giveaway for a poisonous snake here. And you're going to say, well, how close am I going to get to go look at it? Well, the truth is you can see it from pretty far away. If I'm standing here and the snake is over there, you can see it very, very clearly. And the rule of thumb is that snakes cannot strike more than 2/3 of their body length. So if he's 3 feet long, he can strike 2 feet. Anything out of that, he might as well be on the other side of the world. I mean, that's. This guy this is terrible. This is a terrible snake. Get you in a minute. Some people say, oh, that's a death adder. Well, no, it's not a death adder. This is a hog-nosed snake. And we have them, they're fairly common in sandy places. And what they do is they spread their neck, they flatten it out, they hiss, and they strike. And scare the living heck out of you. The only thing is, they don't open their mouths. So they go through all of these machinations of striking and hissing and puffing up and blowing and spreading up wood, doing all these things. And if that doesn't work, they roll over dead. Not only do they roll over dead, but it's really a great act. They roll on their back, they open their mouths, and their tongue hangs out. You say, oh, look, he's dead. You pick it up, and it's like a limp rib. The only thing is, if you turn it back on its belly, it flips on its back. Because to be a good dead snake, you've got to be on your back. So it's really funny to see. And they only feed on toads and frogs. That's it. They don't feed on anything else. So they're fairly common, and they have a little upturned snout like a shovel, and that's why they're called hognose snakes. And it's used for burrowing in the ground, burrowing in the sand. This is one of our larger harmless snakes. This is called a pilot black snake or black rat snake. They get to be about 6 or 7 feet long. And unfortunately, they're almost totally disappeared from this part of New England. Rattlesnakes have also largely disappeared from a good part of New England. These guys are exclusively bird egg, and rodent eaters. And you find them in exactly the same habitat, except that they roam around. They have a big wide range, and during the summer months, they're all over the place. They climb trees. And I don't know if any of you have ever seen a black racer.
Yes.
They're gone.
Different from the pilot snake?
Yes, they're different in that black racers have a white chin, just the bottom of the chin is white. Pilot black snakes, the entire bottom side of the neck all the way down, about a third of the way down the body is white. And if you look at on the back of a pilot black snake, you can almost see white boxes on it. Sort of the scales between the black scales are white. These guys are streamlined. They're just all satiny black. These guys eat a lot of frogs and other snakes.
Do they get as big as that pilot black snake?
They get to be about 5 feet. A big one would be 5 feet long. But most of the time, the only thing you ever see of them is a blur going somewhere.
And there is still quite a few of them, isn't there?
Yeah, in the right situation, yeah. You can. They're still common, but locally. This is a fairly large rattlesnake. This is about 5.5 feet long. And the sting that he's using is called a pillstring tongue. It was made by a rattlesnake, a person out west that thought, gee, we need something to sort of keep your hand away from a rattlesnake. So he created these, and they're very good. They don't hurt the animal, and it's just a pair of grabbers, aluminum grabbers. Now, what we found when we were doing our study is that some snakes, when you bothered them, they hid their head under their coil and made believe that you weren't there. So you could pick it up, you could grab it, pick it up and shake it, and it would still keep its head tucked into its coils, because obviously, if it can't see you, you're not there. And this is rattlesnakes are very timid that way. If you really bother them, then they rattle. And of all of the snakes that we ever came across, I think there was only one that we came across that was in the top of a bush in the hot sun in late August, and it was really hot, and this snake was very agitated, and it would strike at us. The rest of them, you almost never could get them to strike at you. And that's why, I mean, here in Dover Plains, here we were catching all these snakes and marking them and tagging them and doing all sorts of things with them. And there were really no recent records of rattlesnake bites, anywhere around that anyone knew about.
And how many would you find on any given day?
We would find rattlesnakes, copperheads, black racers, pilot black snakes, and garter snakes, mole snakes. In any given day at the dens where all of the snakes from a whole area would have congregated back, we might find 6 or 7.
Yeah.
So we'd go back up day after day after day. And as we were tagging them, we knew which ones we had gotten before.
So do all the different types of snakes
Pardon?
use this? Do all the different types of snakes use the same den? They all
Yeah,
have
they all use the same den.
Even there was one that would eat the other ones. They all.
Yep. Yeah, that's why he's there. The ones that don't go back to these dens are things like garter snakes, worm snakes, and little brown earth snakes that are living around your house and in your garden. They just find a good spot where they're living and stay there. But the larger species, they go home.
How do you tag this thing, electronically, or use a band?
Well, now there's called pit tags. Have you ever taken a temperature? You know, it's a little different than your kid. The kid's not going to turn around and try and bite you. But it's the same principle. You want body temperatures here. We also did swabs so that we can run parasite analysis on the fecal materials. And maybe I shouldn't tell you this, but we used to give them enemas because you had to collect the fluid to look for parasites. That's the way we were tagging then. We put a little, they sell them as little fish tags, and if we would tag it right there at the base of the rattle, because when the snake crawls, it holds the tip of its tail of its rattle up so it doesn't get caught in the pressure knot. Now there's these little grains of rice that are called pit tags, and you can implant them under the skin and read it with an electronic reader. So it's a lot more sophisticated now than when we were doing this study.
Is it true you can know the age of the snake by the number of...
No, it's not. Because they put one of these segments on every time they shed their skin. And they shed their skin about 3 or 4 times a year. And what happens is that this is a complete one because it's got the tip of the tail, the original terminal scale from when the snake was born is there. But as they get older, these things break off. So you may find a rattle with only half a rattle. So you really can't tell by that. You can make a guess, but so let's move a little out of western Connecticut, a little bit closer. This is Meriden, and this is the town, and about 2.5, about 3 miles away is a rock quarry right here, an active one. And right here above the reservoir is the same kind of rock breakdown, that talus slope that you saw before. That's where there are no rattlesnakes there, but there's a copperhead population there. And the Yukon people, well, as you said, they captured and marked and released 115 copperheads there over a 3-year period. And they probably only saw maybe 30% of the number that were actually there. And yet I would venture to say that there aren't many people in Meriden or in this whole area that even know that there are copperheads there. So, inevitably, you're going to ask me, well, what do you do for snake fighting? What is snake fighting? Well, the venom of a poisonous snake like a rattlesnake is a very, very complex group of proteins and enzymes. And from population to population, it varies. But basically, rattlesnake venom, what it does when it's injected into somebody by, let's say, a snake or whatever, when that venom gets into tissue, it literally melts the tissue. It dissolves the cell walls. So a person gets bitten, the first thing that happens is intense pain and swelling. It's no mistaking it. It's not like, well, did I get bitten by a poisonous snake? It's like someone stuck a hot iron into your hand. And in a matter of a few hours, if it's not treated right, it can end up like this. I've seen snake bites where an hour or two after the bite, it looks like the person had gas gangrene for a week.
Is that person alive?
Yeah. Yeah. What happened, they've sold a lot of these snake bite kits where you're supposed to put a tourniquet around your arm or around the bitten part and do an X cut, you know? I mean, that's John Wayne stuff. That's not reality. And what research has discovered over the past many years now, recent years, is that because that venom is dissolving tissue and it's moving, it's as it progressive, it eats up more tissue. What happens is that if you put a tourniquet down on it really tight, it pulls it there. And the damage is going to take, tremendous amount of damage is going to take place there. Doesn't stop it from moving, from circulating through the system. It just pulls more of it in one spot. So a tourniquet actually, where it's used, causes people to lose their hand or lose their fingers from the gangrene and from this tissue destruction. So the method of choice is to take an ace bandage and wrap the whole limb so that it doesn't cut off the deep circulation. It just restricts the capillary flow. And get to a hospital and get antivenin. The problem that we face is that so few doctors have experience treating snakebite that they don't know what to do. And they've got to go back because maybe they had 10 minutes of snakebite in medical school. Snakebite is so rare. So if they're smart, they'll call poison control in Atlanta, get in the system. Poison control will put them into one of the snakebite trauma centers and plug them into a system where they're going to get a doctor who has treated, consulting, who has treated a lot of snake bites. Or the doctor may ask that the person be transferred down to one of the trauma centers. But it's really, really complex, and one of the disturbing things that's happening now is that the Wyeth pharmaceutical company used to manufacture antivenin for all of the species of snakes in the United States. And the way that was done is you inject the venom from various species of poisonous snakes into a horse. A horse is a big animal. The horse produces antibodies because it's big, it can tolerate the venom, and it's injected in controlled amounts. And so it builds up antibodies, and they take these antibodies, they take the serum, and that becomes the serum that the person gets when they're bitten. So you're borrowing, what's happening is an acute, is now. You're going to die now. You're going to lose your hand now. So you borrow these antibodies now until your body can sort of resurrect itself and get on the ball. And the problem is that horse serum, people tend to be allergic to horse serum, and you can go into anaphylactic shock from the serum. So the doctor has to be savvy enough to start treating for shock before shock takes place. And they do that, sort of, But serum is the only way to go. Well, what happened is that a few years ago, when the pharmaceutical companies sort of got a lot more leeway to do what they wanted, Wyeth said, wait a minute, this isn't profitable to us because there are so few snake bites in the United States. We're making this as a public service. So they cut a deal with USDA that if another product came on the market, they would stop making it. Well, another pharmaceutical company came up with a bioengineered product, all right, and Wyeth stopped making the serum. Well, think, well, not so bad. Well, Remember I told you that it's manufactured from a horse's antibodies? Well, that horse is also producing antibodies for tetanus and a whole bunch of other things. So they're not losing out on it at all. At the same time, the nature of the antivenin, because they use so many different species of snakes that were mixed with it, and every kind of snake, rattlesnakes, every population, little slightly different component to the venom that does a different thing. So when you got the Wyeth antivenin, it covered a lot of different populations and a lot of components of the venom. Also, it circulated a long time. So a person getting serum today, those antibodies would be circulating, doing their job for the next week, all right? And they would only require a booster in antivenin over that period of time. Well, the bioengineered stuff is only made from one species or two species. And what happens is that the circulating life, instead of being 2 weeks or so, is only a few hours. So you got to keep giving more and more and more and more serum. The price is way far more than Wyeth. So the price of treating a snake bite went from, to a hospital, went from maybe $50,000, $60,000. Now it's way up, almost $200,000. And so what a lot of hospitals are doing, the hospitals don't stock this stuff. No hospital stocks it. So what they do is, when they have a snake bite, once every 20 or 30 years, they call Wyeth and they get an emergency shipment of serum. Well, what it also means is that the majority of people that are bitten, remember the stereotype I gave you, don't have health care. And the hospitals don't want to foot the bill for $200,000 worth of serum, so what they do is they stabilize the person and send them somewhere else. Well, the longer you take to get the right serum and the right treatment, the more damage is taking place. So that's what's happening. That's what's happening. So the moral here is don't play with poisonous snakes. You can't afford it. So we'll go away from the poisonous snakes for a while and look at this. Now, pulling it down now, the circles, what they do is they don't want to identify locations where where these things have been collected. So it's pretty general. But you can go into DEP, you can go throughout the state. Most states have this now. It's the same, they have water use maps and forest maps and wetlands maps. And these maps of endangered species should have been sent, or were supposed to be sent to every, every town clerk's office throughout Connecticut for their area. And of course, we're one of the richest places in wetlands, and so it makes this part of the country so gorgeous. And Hartland is how much is wetland and how much is dry land? I always laugh at the arguments that, as I said, I'm on zoning, is that, well, we want open spaces, we want to put in a golf course, or we're going to have an open space, so let's put in a recreation field. Well, all of those things are important, and people like to have them and so on. But those are not habitats. Very little lives in the middle of a golf course. I mean, the stuff that lives in the peripheral forest lands and in little patches, but not much lives on a golf course, and certainly not much lives in a recreation field. And we just made we made a terrible mistake that we put in this gorgeous, gorgeous recreation field. And of course, the architect that designed it wasn't used to working in a place like, I mean, I came out of the Central Park Zoo. and where every square inch of real estate, literally every square inch is worth tens of thousands of dollars, we wouldn't dare cut down a tree, even a dead tree in Central Park, without going to the Commissioner of Parks of the City of New York and getting approval. And he'd send out his foresters and the arborists and so on before we would get permission to cut down a dead tree. Because there may be an owl living in there, maybe a nesting place for a hawk or whatever. But in Harlington, when we decided to do a playing field, first thing we did was we clear cut it down to the ground. You don't have to do that. I mean, it's a little more effort and a couple more bucks. You protect you get a forester to go in and identify the future trees and get those to remain and build the recreation areas around critical trees and critical habitat. That's my swimming pool. I decided that kids are my son's came out of college, his friends are all married. Now's the time to get rid of the swimming pool and put it to where I really would like to see it. So I haven't resurrected it in 5 years. It's not costing me $3,000 a year in electric cost to filter it. I don't dump all of these chemicals into it anymore. I let it cycle by itself, and about a year and a half, 2 years ago, I dumped 1 handful of duckweed into it, and that's duckweed now. and my son's a civil engineer, so he likes to see concrete and buildings and stuff, and he looks at it and he goes. In any case, my wife is a science writer. She writes for scientists. She writes science articles and reviews. And so she was writing an article about 2 years ago on colony collapse in bees, where the bees were disappearing. And so we went to a bee conference in Connecticut and met all the beekeepers and so on. And there was this one beekeeper who said, "Man, I'm looking for a place to put my bees." And, "Come on." So he put up 1 hive 2 years ago, and now he's got 5 hives. And I don't do anything. I mean, I go out and say hello to him. That's the extent of my labor. And at the end of the year, I get a couple of nice jugs of pure honey. And it makes my wife very happy in the wintertime. She's got a sore throat. And I left the adjoining field in goldenrod, and I don't hardly hear my neighbors sneezing across the room. But there are these little things you can do. You can plant plants that are attractions for a wide range of insects. At the end of last year, I bought, I think it was at Price Chopper in Torrington. I bought a bunch of butterfly bush for it's like $4 or $5 a piece, and planted them around. And this year the monarchs are using them, and the tiger swallowtails. It's just this constant flow of butterflies coming in. And bumblebees and honeybees and moths and hummingbirds have come in this year. We've seen loads of hummingbirds. So, just stop for a minute to understand what an amphibian goes through. It starts off, the eggs get laid, the eggs go through a larval stage and then become tadpoles. After a period of time, the tadpoles absorb their tail and grow hind legs, and eventually they develop into large frogs, which then go off. So those are the stages, and from egg stage to the metamorphosis stage, they're in the water. So what they're finding worldwide is that because amphibians absorb, their skins are highly absorbent. So they suck in water and they lose water through their skins. And in fact, when frogs hibernate, they frequently can get frozen in ice, but they can take in enough oxygen through their skin to stay alive. Some are better at it, and they found that some frogs, actually the blood of some species of frogs that live in really the northern climes, it's a kind of antifreeze that keeps the animals from freezing to death. And so, if you've got healthy frog populations, you've basically got a healthy environment. And if you begin to see frogs disappearing, and the way you tell frogs are disappearing is in the springtime, listen to the choruses. When you don't hear the choruses in April and the beginning of May, you start thinking, well, what's happening to the frogs? And it doesn't take much to destroy a population of some species of frogs, and I'll show you in a minute. Now, have you, you've seen spotted salamanders? Yeah. All right. There are probably millions upon millions of spotted salamanders, and let me see if I can go back here. No. There's millions of these spotted salamanders. They're about this big. And about 3 years ago, we just happened to have a warm rain in the spring at just the right time, and the roads were covered with them. And what happens is these guys live in the forest, and in a very short period of time in March, they all march down to some little puddle of water, and it's in a place where the spring rains have thawed. The ice is still on, maybe some skim ice on the water, maybe some snow left on the ground. But by and large, you're in the period when the temperatures are rising and spring is coming. You're just at the cusp of spring. And while it's still cold, they all march down to the water. They get in the shallow water, usually the flooded, marshlands and old farm fields with tussocks of grass that get flooded is perfect habitat for them. And they do like a dance. The males get down and they swim around in a circle with the females. And the males drop these packets of sperm. Females pick up these packets and stuff it into their cloacas and start developing egg masses. Anyway, that gelatinous mass that you saw it looks like a ball of jelly with little black spots in it, and it's stuck to the branches that hang into the water. And within a couple of weeks, they'll hatch out into this larvae form. And if you look at here, these little frilly things, they have external gills. This is what they're taking the oxygen out of the water. And pretty soon, over a period of another couple of weeks, they'll start turning into little baby salamanders. And within another couple of weeks, so from beginning to the time that the salamanders leave, it's about a month. And they get back into the forest and they spend the rest of the year in the forest until next spring when they all go back. So drain that little vernal pond or drain that swampland or pollute it, and every salamander within a half a mile is probably not going to have a place to breed.
Could you call that a tadpole?
Well, it's the equivalent of a tadpole in a frog. This is a nymph, and in a tadpole, it would be the next stage, which would be a tadpole. Remember, you get out there in the spring and you hear this crazy peeping sound. I mean, these guys are only this big. And there are thousands upon thousands of them in a healthy habitat. These spring peepers. If you look at the toes here, see its little round toe? That's a suction cup. And sometimes they use that, they can climb up glass with it. And sometimes in the summertime, if you're in your kitchen and you're having something going on and the moths are against your window, you'll also see frogs sometimes attaching themselves there, taking advantage of your light to catch insects that are attracted to it. So the first ones to arrive are the salamanders while it's still while the ground is frozen and there's still ice on the ponds. The second ones to arrive are these guys. These are the wood frogs. They look like little robbers with their mask. So you got this procession of species, one following the other. So it's first the peepers, then the wood frogs. These are wood frogs. Here's the male that's dropping his sperm, and she's pushing out her eggs at the same time. And here's the egg mass. And these will go through the same thing. They'll go through a period of time. Here's more eggs. And eventually, when she's done laying her eggs, he releases her, and then they disappear. They're back in the woods again. After just about the time that these guys are getting done, the toads are coming in. And you can tell when the toads are arriving, and if you listen, the peepers peep, the wood frogs clack, they clack, 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 and the toads trill. You'll hear this trilling sound. So already you can pick out 3 species that are doing their thing. And then last, these are the gray tree frogs. And you hear these guys yelling and screaming, and they're making just a racket of clacking sounds up in the trees all the way through to the end of July. And they love evergreens. So I've got some cedars around the pool, some big old cedars, and the gray tree frogs are just coursing out of the cedars almost all summer long. And the last of these bozos. And so here's this whole entourage taking place from spring into midsummer. And you have green frogs and bullfrogs. And the way to tell the difference between the two is that, you see this line? This is a sensory line. It's called a lateral line. And the green frog, it's called a lateral fold. And so green frogs have it, and bullfrogs don't. And if you look, this big round disc here, this is the frog's eardrum. And you can tell males from females because in the females, this eardrum is the same size as the eye or smaller. And in the males, it's bigger than the frog's eye. And the reason it has such a big eardrum is because it has to see other frogs calling, or has to hear other frogs calling. Now here, these are bullfrog tadpoles. You can see they've just grown their legs, and they're still in the water, and they'll be in the water. And bullfrogs, unlike the other frogs, because there's so much competition, bullfrogs are so big, they need more energy, they have to grow longer, that what happens is that the other frogs all do their thing, and they're out back in the forest within a couple of months. Bullfrogs, the tadpoles spend 2 years in the pond. So the eggs are laid this year. They don't turn into frogs until next year.
Is that the same with green frogs?
Pardon?
That's the same with the green frog?
Yep. Mm-hmm. It's 2 totally different species of frogs. Some of these salamanders, like this redback salamander, it's only about this big, never goes to the water. it lays its eggs in a mulchy spot, where it's very moist on the forest floor, and it hatches out on the forest into baby tadpoles, and goes through basically the same size. This is a developing embryo in one of these little salamander. And there's probably about, I didn't count it, there's probably about 10 species of salamanders that live right around here that you never see because you'd have to go out and turn over rocks and logs and so on in different habitats. And this was the most curious. Have you ever seen these little red guys? Sure. Yeah, that's a red F. And they call them red Fs because they're red. But you see them on the forest floor trucking around. Well, what happens with these guys is that after the eggs are laid in the water, they go through this nymph stage and they transform into this red F that goes back off into the forest. And I've seen red Fs up at the rattlesnake dens 900 to 1,000 feet above sea level. That's a lot of walking for a guy with legs maybe 1/8 of an inch long. In any case, come spring, they travel back down to the ponds, they turn green, lay their eggs, and then the eggs hatch again and turn into red Fs. But the green newts, now they're called green spotted newts, they spend the rest of their lives in the water. They never leave again. So all of these strategies are designed to adapt to specific habitats and to not compete for the same food item at the same time. So it's like someone said, hey guy, you're allowed to be here from Monday through Friday at 6 o'clock, but you are not. You got to wait until 7 o'clock. Unfortunately, billions of frogs are consumed by hungry humans because people are starving to death around the world, especially in areas, in places where there's wars, famine, and so on and so forth. I went on an expedition to collect these giant frogs in Cameroon a number of years ago, and these frogs are about the size of a fox terrier. And what we found about them is that one of the people on our expedition was a physiologist from Oklahoma State University, and his theory was that a frog that big can't live. And the reason it can't live is because in the evolution of frogs never developed the same circulatory and respiratory system that was big enough to support such a big mass. And he said, can't live. I said, well, here it is. Well, he was right.
Higher education.
He was right. Because one day we had left word in the village that we were going to buy any giant frogs that the hunters would come up with. This is the fellows that I'm saving there are the village hunters, frog hunters. And they eat frogs. I mean, there's lots of meat on those legs. And so this woman came out the next day with a pot with frog in it. And when she took the lid off, the frog hopped out onto the ground and started hopping across through the village with a whole bunch of kids behind it. And lo and behold, it went about 20, 30 feet and rolled over dead. Because in fact, it could walk, it could stay calm, but if it got too upset and burned up all of its sugar and all of its oxygen, it went into cardiac arrest, had a heart attack, and dropped dead. And later on, when we got some back from the United States and we ran some of them through the lab, he could measure all of the oxygen flows and so on. It's very interesting. Right now, we're really facing a major, major threat. And you say, well, what good are frogs? Well, I'll tell you. I was trying to go online and find out how much food a frog eats. Of course, it's relative to the size of the frog. But each frog, it's just like the bats. Bats and frogs, these little guys, consume a huge amount of food relative to their body weight in insects. When the frogs go, the insects arrive because there's nothing to wipe them out. And So one of the things that's going on right now is a disease that's being called chytrid for short. It's called trichomycosis. It's a fungal disease that suddenly emerged. It's been there all the time, but it's never been harmful. And it's going around the world, and it's wiping out the frogs. And it's wiping out, I mean, frogs are going in 1 year from being abundant in some places to being extinct, gone totally. And what we think, the best that we've been able to come up with so far is that as warming is, the globe is warming, that this minute change in temperature is allowing some things to proliferate and other things not. So fungus that couldn't live at just a tiny, tiny degree warmer or colder, now is getting a more favorable temperature and it's infecting things. Also, they think that the reason it's being spread around the world is because as more people are eating frogs, the industry is taking frogs from one place and transporting them to other places. And it's a highly infectious disease. So no one's come up with a way of stopping it yet, but we're going to lose major portions of the world's frog populations before it's over. And I want to point out down here to PARC, P-A-R-C, Partners in Amphibian Research and Conservation. It's an organization that, because frogs were disappearing, and we picked up on it pretty early in the game, they started this organization that's all over the United States, including here in Connecticut. And if you go online and just put in PARC, Partners in Amphibian Research and Conservation, it's such a huge job to monitor what's happening with frog populations that they've got just volunteers that are willing to go out in spring and count frogs, do frog recordings, because now we're analyzing frog populations by the density of the calls. So it's very worthwhile. And if you feel like doing something that's really interesting, get yourself out there in the springtime with a flashlight and start looking and trying to find these little guys that are making all of the racket. Contact PARC, and if you've got some time to volunteer, you can volunteer. They'll tell you exactly how to do it and train you to do it. So right now, there's about 6,060 frog species in the world, and 1/3 of them are going to disappear before our very eyes. And you can see the diversity of different kinds of frogs. And that's an azure dark frog from Costa Rica. Gorgeous, isn't it? The diversity in amphibians is mind-boggling. This guy here, this is called an ornate horned frog from Central and South, actually from the Amazon basin. Gets to be about this big, and it's got teeth. And so it can easily take down a mouse or some small mammal or bird. And they just sort of sit there and wait for something to go by. This is called a tomato frog. This is what's called a strawberry frog for obvious reasons. This is a glass frog. How it ever evolved so that you can see through its body and its internal organs. I mean, just no matter where you look, there's some absolutely fabulous looking little guy sitting somewhere.
Is that fungus visible on the frog?
Pardon?
That fungus that's affecting the frog, is
Yeah.
it visible?
They are culturing it, but usually the frog dies pretty quick before it's visible. It can be cultured, and that's the way they found it.
So if you saw a frog, you wouldn't be able to tell it.
No, you would not be able to. Usually the way you tell that it's got it, you're at dead frogs. And of course, then it's too late. It's like the bats. I mean, we see a bat and we say, oh, there's a bat. But bats are so high metabolism, they eat so many insects in the course of a night, probably more than their own weight in insects every night. And they're disappearing from another fungus. That was the white lip fungus.
Yeah.
You see a little white blotch on the what do you call them, the bat's lips. And one of the things you can do is put up bat boxes. And that's what I'm going to do this year is put up some bat boxes. And they're easy. You just make a wooden box that's sort of 4 walls close together with a top on it, and line the inside, the stuff that you use for the green pad used for scouring your pots and pans with. You line the inside walls with a staple to the wall, and you leave the bottom open. And bats go in and hang on to it, and it's a great place for attracting bats. So I'll end up with, this is what we're going to have to go through before we get to the other end. Well, thank you very much.
Going back to the chytrid fungus,
Yeah.
is there any indication that it's being passed on to avian populations by, say, a heron ingesting?
No, I don't think so. I haven't read that. But it is so new. I mean, yes, it's been around, we know it's been around for a couple of years now. But it's like, how do you get your handle on a disease that's global?
Yeah.
With frogs, that are so sickly, you can only deal with them in a short period of time every year. Yes.
Is there anything to the lore that there's an intense odor of cucumbers when one is near a rattlesnake?
No, has no meaning at all.
Okay.
No meaning at all. The last time, I remember someone telling me about that, and I think they traced it to a cucumber sandwich or something. If you irritate some snakes, like water snakes, common water snakes, and you see them in all the ponds here, and they're always mistaken for cottonmouth water moccasins. The furthest north that cottonmouth water moccasins come is the Dismal Swamp in southern Virginia. That's it. They don't get any further north than that. Anything else is not a water moccasin. But there's lots of water snakes, and water snakes, they don't bother you, they don't attack you, they don't do anything. But if you grab one, it'll bite you. And the bite is harmless, it's just like pinpricks. But they also throw their tails around and give off with a musk that's absolutely vile, and it doesn't wash off. Yes.
Any of those dens, the snake dens, are any of them in this area, or are they all further
Rattlesnakes
away?
have been wiped out through most of Connecticut. The only place that timber rattlesnakes still exist is along that that mountain ridge up into Massachusetts, and in Glastonbury. Right in the middle of the state, there's a population of timber rattlesnakes. Yeah.
I heard somewhere, I think, that rattlesnakes can't kill a healthy adult. Is that true?
No, that's not true.
Not true.
Copperheads rarely can kill a healthy adult.
Yeah.
All right, and any deaths from copperhead bite, usually a small child or someone that's older, has other problems. But a healthy rattlesnake bite, a big rattlesnake, the probability is the vast majority of people survive snake bite. And timber rattlesnake bite is serious. If you're lucky, you get the treatment. You see the terrible looking arm, all goes away, all clears up with the antidote and the right treatment. With the wrong treatment, the arm is gone. Rattlesnake bite, mostly survivable. It's unusual for someone to die from that kind of rattlesnake bite. Originally, all of the studies done on the effect of snake bite was done on western diamondback rattlesnakes out west, okay? And when people use the same treatment on eastern diamondbacks in Florida and Georgia and Arkansas, people died, lost limbs. The reason behind it is that even though the two species are closely related, the venom is much more potent in the eastern diamondback than the western diamondback. And now we're seeing, just like you saw the variety of frogs, there's a wide variety of venoms from a wide variety of snakes. One of the snakes that's found in Afghanistan and in that part of the world in North Africa is a little snake called the saw-scaled viper. It doesn't get any bigger than this. And what it does is it coils up, and when it coils up, it rubs its scales together and makes a buzzing sound. And it's a very nasty snake. It's found under rocks in the desert, all right? And when you can, and it usually bites, as soon as it starts striking, and so it's most apt to bite somebody. It kills a lot of people. And the reason it kills them is that the venom of this little guy, has a component in it that causes, let me see if I've got it. It eats up all of the clotting, factors in your blood. So you bleed out into your internal organs, mucous membranes, your eyes. You literally bleed to death within yourself. And this happens very, very quickly. It's acute disseminated intravascular, what's the last word I'm looking for? Coagulopathy. And the only way to save a person is with antivenin and with injecting them with some coagulating factor. So it's a nasty little snake. There's another, one of the cobras. There's a whole array of cobras around in Africa and Asia. One of the cobras is called the yellow cobra from South Africa. And the snake feeds on other snakes. So you gotta imagine, the snake is hard to kill. So its venom has got to kill another snake. It's got to do it quick. Otherwise, the snake's going to get away and it misses its meal. Well, that snake has its venom. What it does is it immediately blocks the transmission of messages to the muscles of the heart, and it targets those muscles. So the heart doesn't beat. It's got to stop beating. You can't make it beat. And the person dies very quickly because they eventually, no heartbeat. We had a guy that at Jacoby a number of years ago that was bitten by his pet yellow cobra. And we had never seen yellow cobra bite. We didn't know anything about this. And one of the side effects is that person that's bitten by it gets totally paralyzed, and for all practical purposes is dead, except for a little bit of brain function. And so, I mean, here's this guy, it's like a couple of hours post-bite, dead, he's dying. He'll be dead in a few minutes. So our snakebite trauma surgeon said, wait a minute, he may be a good donor. So he goes upstairs and he gets whatever the specialty is that does transplants and collects donor parts. And we're standing around this poor guy, and he's talking about, gee, what can we get from him? I mean, his eyes will still be good, this part will be good. And we look and the guy starts crying. He could hear everything that was going on. He had no ability to move. And our surgeon specialist said, oh my God, this guy can hear us. His name was Rudy. Rudy, can you tell us something? Make something, blink, your eyelids. You move the tip of his toe. That was it. We loaded him up with serum. Fortunately, I had enough of the right kind of serum to do it. We loaded him up with serum. The next day, he was looking for something to eat. Orioles don't play with snakes.
Do you have one more question?
Sure, yes.
I have a pond, and every 4 or 5 years in July in the evening, especially if it's humid, I have some sort of frogs there that sound like it's the Amazon. What are they? They're very loud.
July, it's probably just those little gray tree frogs.
That's what they
Yeah,
are.
they're about that big. Go out at night with the flashlight and just follow the sound. And if you can get a tape recorder and record it, in other words, record it from a distance, because when you get close to them, they stop calling. All right? Play the call, and they'll start calling to them again. And you can home in on them and see them.
Do they do this just when they're mating? I mean, we don't hear it every
It's all
year.
just during the breeding season.
4 or 5 years.
Yeah, just during the breeding season. As a matter of fact, I don't know if I can do it. I'll try.
I remember the picture that you had. That was
This is a little yellow because of the light of the flashlight, otherwise they're grayish green. Look at me, ain't I beautiful? I got a bigger throat than everyone else.
Sure, it's not on us.
A face only a mother could
it's
love.
only birds, actually.
And that was taken on the top railing of my swimming pool.